Review again. Factoring polynomials. Factoring is, and it says it in this opening sentence here, or opening paragraph here, it is one of the most important skills in algebra. Okay, you have to understand what factors are, what the meaning of them, what's the meaning of them, and how to factor everything, monomials, polynomials, everything. Okay, so here you'll see on your screen, and you have it on your paper, two important meanings or definitions of the word factor. When you say factor, it could be a verb or a noun. I know I'm getting, this is in English. Why are we doing this? Well, because there's two. You could say, hey, I want you to factor something. All right, that would be a verb. You're going to factor a polynomial. You're going to actually do something. That's a verb. Okay. If it's a noun, it's just it could be, like it says, any individual component of a product. So like if I say 4x, okay? 4 and x are factors. 4 is a factor and x is a factor because you're breaking it down. 4 times x. If I give you the number 8, that could be 4 times 2, right? 4 is a factor. 2 is a factor. Those are nouns. So that's using the word factor as a noun. If I say factor 8, factor the number 8, you would say 4 times 2. But you're performing something. So it's a verb. It's an action. Anything that's an action is a verb. So that's why there's two different meanings, two different definitions. So what I'm going to ask you to do is factor, verb, these quantities here. These are things, again, these are methods, these first three methods, these are all things that you should already know coming in. We expect that you do, but we are reviewing them because we know it may have been a while since you've done it. So factor each of the following by factoring out a greatest common factor. I know you've heard that before. You're trying to find the factor between the two terms. We have a binomial here. We talked about the vocabulary before. We have a binomial, and we have to look for what would be the common factor of this binomial. Well, here I have an 8, and here I have a 12. The greatest common factor between 8 and 12 would be 4, because 4 goes into 8 evenly, and 4 goes into 12 evenly. So I'm going to pull out a 4 here. You're going to write that on the outside of the remaining quantity. The remaining quantity will have to still be a binomial. If you're using this method and you start off with a binomial, you have to end up with a binomial. You cannot go from a binomial down to a monomial. There has to still be a binomial there, and you'll see why. So 4 times what gives you 8x? 2x. And 4 times what gives you 12? -3. So now what you're actually doing is the distributive property backwards. Distributive property backwards. If I distribute now 4 times 2x, what do I get? 8x. 4 times -3, -12. Voila, 8x minus 12. That's the idea of factoring. It's basically dividing. It's going backwards from the distributive. It's the reverse of the distributive property is all it is. All right, here we have a 9 and a 12, so 3 would be the common factor. And then we have x to the 5th, x to the 3rd, so x to the 3rd would be the common factor. And nothing with the y, so that'll be on the outside. On the inside, we're going to have, we need another 3 because we took out 3 times 3 is 9, x squared, and then minus 4. We don't need any more x's. If we put an x there, it's going to become x to the 4th. We don't want that. We want x to the 3rd. It's already there. You just need to have a y there. So now if you distribute this out, you should get this. All right, so for number 3, you're going to be looking for a common binomial in this case instead of just a common monomial. And it does kind of, it sticks out at you. If you look at this part over here and this part over here, you'll see that there's something in common. But it's not like just an x or just a 2. It's the x minus 4. See if you, I'm going to highlight it here. Okay, this x minus 4. That is what's common between these two terms here. If you look at this, and this is a term. This is what's common. So what you do is you'll pull out that x minus 4, and then the 2x plus 3 kind of goes together in its own in its own binomial. It's kind of weird. It's like, well, how does that work? Well, the x minus 4 is the common factor, so that kind of gets pulled out, and then what's left over is that 2x plus 3. It does work out. Okay, if you multiply this out and multiply this out, you'll get the same thing. So let's do that real quick. This one here, well, I'm not going to, actually you could do it. I'm not going to do that right now because I don't want to lengthen the video, but you could multiply both those out and you would get the same thing. All right, difference of two perfect squares. This should be quick. In order to see the difference of perfect squares, you need to be able to multiply these binomials. X plus 4 times x plus 4, that's x squared. And then you got to FOIL. You got to, well, FOIL or each with each. Everything gets multiplied by everything. X times x is x squared, and then plus 4x. And then inside is going to be plus another 4x. And then 4 times 4 gives you 16. So that's x squared plus 8x plus 16. X minus 4 is x squared minus 4x plus 16, and you guys should know this already. That's why I'm kind of going fast. And then x plus 4 is x squared minus 4x plus 4x minus 16. The 4x and the minus 4x are a zero pair, so that goes down to nothing, and you're left with just x squared minus 16. So I want you to notice how when you have x plus 4, when the plus, that will give you a trinomial. When you have minus, it's going to give you the trinomial. Only the plus minus gives you that binomial. So that x squared minus 16 could be factored to this. See, these are the factors of these. Okay? So these are the polynomials, and these are the factors. So if I have x squared minus 16, my factors must be x plus 4, x minus 4. So what we're going to do is use that. It turns out these are called conjugates. This is probably a new vocabulary word for you, conjugates, if you haven't heard that before. Anything that's x plus a, x minus a. X plus a times x minus a are called conjugates. And it's got to be a plus and a minus, and these have to match. The first and first have to match, the last and last have to match. They have to be the same exact letter or number. It doesn't matter. So x squared minus 81. This can be factored with conjugates because x squared is a perfect square and 81 is a perfect square number. So I can set up my two binomials, which are also going to be conjugates. X times x gives me my x squared, and a plus 9 and a minus 9 gives me my 81. And it only works if you have a difference of perfect squares. It's got to be perfect square numbers. What about here? Well, 9 is a perfect square, 3 times 3. X squared is x times x. The 1 is tricky, but you got to understand, 1 is 1 times 1. So it does work. And you have to keep the order. It's 1 plus 3x, 1 minus 3x. Here, I threw a fraction in there, not a big deal. Everything's still a perfect square. 5x plus 1/4 and 5x minus 1/4. It's that simple. These are all conjugate pairs. Conjugate pairs. Right there. Meant to circle that. Sorry. Okay. Our last method that you would have learned coming in is the guess and check method. You may have heard it called reverse FOIL. We're not going to use that terminology, that FOIL terminology, because in Algebra 2, we're not just going to be doing binomials. We're going to be doing trinomials and fourth-term expressions and everything. So there's going to be a lot more to it. And we can't be using that FOIL thing anymore. So basically, we're just going to call it a guess and check technique. And you're going to set up your binomials because there is no common factor here. So we're going to set up our binomials. We know that to get x squared, it's going to be x times x. And we know to get 35, I want you to set up a factor tree, 35, or a t-chart. It could be 1 times 35. It could be, and that's it. Oh, I'm sorry, it should be 5. It could be 5 times 7, and that's it. All right, so it's got to be either 1 times 35 or 5 times 7. You're looking for a difference of 2. So it must be 5 and 7. And we need to figure out what the signs are. Okay, so x times x is going to give you x squared, and 7 times 5 is going to give you 35. They have to be different signs in order to get a negative 35. So it's the inner and the outer that you have to worry about. You have to figure out where the signs will be. Well, I want it to be a positive 2x. I want a positive 2x. So do I want a positive 7x and a negative 5x, or do I want a positive 5 and a negative 7? Well, it turns out that I want a positive 7 and a negative 5, because that's going to give me a 7x here. It's going to give me a negative 5x here, and that combined is going to give me my 2x that I need right here when you do your multiplication. Here, x, okay, 50 is either 1 times 50. Think of the different ways you can multiply and get 50. 2 times 25. 3 doesn't go in. 4 does not go in. 5 times 10. 6 doesn't go in. 7, 8, 9. They don't go in. So it's it. Okay, so those numbers go in. And then we're at 10, so obviously 10 times 5. How are we going to get this negative 5? All right, so we got to get a negative 5 from 5 and 10. So we're going to use 5 and 10 here. And I got to get a negative 5x. All right, that's what I need to get when I do the inner and the outer. Okay, the inner 5x, and I want a negative 5x. So therefore, I want this to be a positive 5, and I want this to be a negative 10, because that gives me a 5x here, and it gives me a negative 10x here. And when I combine 5x and negative 10x, it gives me my negative 5x that I need. All right, so that is how you would do those. The reason I showed you this method is because of these guys right here. And these are going to be our last two examples, and we'll do one for a warm-up. But what we need to do now is figure out, and you're going to do a little bit more guessing and checking here. I know that to get 2x squared, I'm going to need a 2x and I'm going to need an x, because just x and x is going to give you x squared. You need 2x squared. So now this changes things a little bit. I still need 6 on the end, so I'm going to think of ways I can get 6. 6 can be either 1 times 6 or 2 times 3. 2 times 3 or 1 times 6. Now, to get a 7, you might be thinking it's 1 and 6. But what you have to realize is, remember the inner and the outer thing we just did? Whatever number goes here, whatever number you put in this slot right here, that's actually going to get multiplied by 2 when you do the outer. So if I put a 6 here, it's not really a 6 when you talk about getting the 7x. If I put a 6 here, it's really a 12. It's going to give you a 12x. Okay, so if I do I wouldn't want a 12 and then a 1. That's not going to give you 7. So let's eliminate that. The 6 can't go here, because if I put a 6 there, I have a common factor of 2 and 6, and that would never be. You could not have a common factor there. So that's not going to be it. Get rid of that 6 right there. Remember, whatever goes here is going to be your... It's going to get multiplied by 2. This can't be a 2 either. This can't be a 2. If I put a 2 there, I have a common factor. Again, you cannot have that common factor. That's never going to be there. So let's try. Now I'm just guessing and checking here. But let's try a 2 here maybe, and a 3 here. I think that's the only way it's going to work. What's my inner? 3x. And my outer is 4x. And look at that, 3x and 4x can give me 7x, but I want it to be a negative 7x. So I want this to be a negative 3x, I want this to be a negative 4x, and therefore this must be a negative 3, and this must be a negative 2, because when I do the outer, it gives me negative 4x. It's kind of just like a puzzle, all right? You're trying to figure out what needs to go where in order to make it work. So this way I got my positive 6, I got my negative 7x, and it works. All right, and one more, 3x squared minus 4x minus 15. So we're going to try and we're going to put our parentheses in there. And we know it's got to be 3x times x to get me the 3x squared. To get 15, it's either got to be 15 times 1 or 5 times 3. Now, I'll tell you a hint. you're never going to have a 3 here when there's a 3 here, because that's a common factor, and we don't have a common factor up here. So I know there's no 3. Also, you would not have a 15 right here, because a 3 and a 15 has a common factor. So definitely not a 3 or a 15 here. So I'm going to try putting a 5 here first, and then that means this would have to be a 3, and then we'll just see if it works. This is 5x, and this is 9x. So this gives me 5x, and 3x times 3 is 9x. And then that right there is a difference of 4. See, 5 and 9 is a difference of 4. 5 minus 9, we want a minus 9, we want a positive 5. 5 minus 9 is negative 4. 5x minus 9x is negative 4x. So I need this to be my positive, and I need this to be my negative. The negative there makes it negative 9x, and the positive right here makes it positive 5x. And I will see you in class tomorrow.